In this lesson, you will learn how to simplify expressions using exponent properties. Let's look at our first example. We have m to the 0, q to the negative 17, all over k to the negative 9th. So in order to simplify, let's use our exponent properties to simplify each piece at a time. So let's first notice, for our exponent properties, we have this m to the 0, which matches the first property, which says anything to the 0 power equals 1. So let's replace that m to the 0 with a 1. Of course, everything else stays the same. Q to the negative 17th, k to the negative 9th. Really, with this 1 of a coefficient in front of the variable q, it's not required to write a coefficient of 1. So really, the property m to the 0 does change to a 1, but as far as needing to write it, it's not necessary to write a coefficient of 1. So let's look at our next part. We have a q to the negative 17th. Well, notice that's property 2. Anything to the negative exponent becomes positive when it gets flipped to the denominator, so we'll need a place value holdover of a numerator of a 1. So let's do that with this q. The numerator's going to become 1 because we're moving that q out of the numerator, so something has to go in its place. Of course, the k to the negative 9th will stay. K to the negative 9th. We've not done anything with that yet. This q to the negative 17th becomes in the bottom as q to the positive 17th. Using that property that says, hey, I've got a negative exponent, it becomes positive by moving to the denominator. So our last part is to deal with this k to the negative 9th. Well, just like the q, if it's negative, it can be flipped now to the numerator in order to become positive. So this k to the negative 9th will be moved to the numerator, so 1k to the negative 9th. Once again, it would not be necessary to write the coefficient of a 1, but since you had it there from the step before, you might want to keep it. The q to the 17th will stay in the denominator because only the k to the negative 9th moves and actually moves to a positive exponent, so I need to write positive 9. So our final simplified answer would actually be, without the 1 as a coefficient, it would be k to the 9th over q to the 17th, our simplified answer using exponent properties. Let's look at example number 2. Here we have the entire fraction h over negative 6. All of that is raised to the negative 4th power. So again, let's look for an exponent property. We have the negative exponents here on properties 2 and 3, but notice our entire fraction is raised to a negative exponent. So this property 9 is the one we'll use. Notice when using this property, we take our fraction, we flip it over, so the numerator becomes the denominator and denominator becomes the numerator. And by flipping it, it makes our exponent become positive. So let's do that step. When you flip it, the 6 and the h stay as they are. They just move the position as they're in the fraction. So that, like I said, the numerator becomes the denominator becomes the numerator. By flipping that, it makes the 4 become positive. Notice the property does continue where you apply the exponent to both the numerator and denominator. So really it's the final step, like property number 8. So the negative 6 gets the 4th power, and the h gets the 4th power. It is important that you put the negative in parentheses anytime you are dealing with exponents and your base number is a negative. Be sure to use parentheses around that negative value. You can stop here because you have used your exponent properties. If you want to punch this in the calculator and do negative 6 to the 4th power, you can do that. It's 1,296 and leave it over h to the 4th. However, using exponent properties is what we're wanting you to use, and so this is far enough. But make sure if you do punch that in the calculator, You use parentheses around that -6 because they do matter when using your calculator. You've got to tell it, I want to do the entire number to the 4th power. Let's look at our next example, number 3. We have m to the 3rd, m to the 6th, and all of that is raised to the 4th power. So let's look at our properties. We noticed here that we've got some variables that are the same. Like in this property number 4, we have the same base, but our numbers as our exponents are different. We have a 3 and a 6. Even if they were the same exponent numbers, this property tells us we can add. So we'll take m to the 3rd and add the m to the 6th, making that m to the 9th. We haven't done anything with that 4, so let's just leave it raised to the 4th power. You can only do this property of adding the exponents when you have like bases. If that would have been a different variable, we would not have been able to add them together. So let's look at the next property. This is a power to a power. So notice the property here. When it's a power to a power, you multiply. Notice I'm stressing those P's. Power to power multiply. So m, 9 times 4 is 36. So that makes it m to the 36. So that is completely simplified now using our exponent properties. Let's look at example 4. Here we have a to the 4th, a to the 9th, a to the 4th divided by a to the 9th. And all of that is raised to the -2 power. There's different approaches you could take with this problem to begin with. Some people like to deal with the outside and work in. I prefer working from the inside to out. So I'm not going to deal with this -2 just yet. I'll hold off on that. I like to deal on the inside. So my a to the 4th divided by a to the 9th. So notice this property that says if we have our exponents where the bases are the same, so we do have the same variables. If we had different variables here, we would not be able to use this property. But if we have the same bases that are being divided, it says we can subtract their exponents. So we'll have 4 and take away 9. So 4 take away 9 gives us -5. We've not done anything with that -2 exponent, so we'll leave it there on the outside. So now that is one of these that is a power to power multiply. So negative times negative is a positive, and 5 times 2 is 10. So that simplifies to a to the 10th. Let me show you another way you could work this and show you it still is going to be the same using our exponent properties. So if you did want to start with dealing with that -2 first, notice the property said if we have a negative exponent on our fraction, we can flip the fraction. So let's do that. A to the 9th, a to the 4th, where our numerator and denominator, they stay the same, they just flip the positions that they're in. And by doing that, our property says that our exponent's going to become positive. So that's going to become a +2. We can go on to finish this property to say we need to apply that exponent to everything inside. So we're going to apply that 2 to the a to the 9th. And we're going to apply that 2 to the a to the 4th. So by doing that, we get a power to power. So once again, we'll multiply. Power to power is multiply, so that's a to the 18th. Power to power multiply, so that's a to the 8th. So we'll have to use the next property of like bases, we subtract the exponents. So 18 take away 8 gives us 10. So notice it does come out to be the same answer. It requires a few more steps doing it this way, but as long as you properly use your exponent properties, you can use either method to get to the final answer. Let's look at example 5. Here we have b to the 11th over b to the 3rd. All of that is raised to the -1 power. So a lot like the last problem, you can approach this different ways. I first see the inside that they have like bases. I'm going to go ahead and combine them together by subtracting, because our property says when we have like bases, we can subtract their exponents. So 11 take away 3 gives us b to the 8th. We've not done anything with that negative 1, so we need to keep it raised to the negative 1 power. Here we have a power to power, so we'll multiply. So b to the negative 8th. We cannot stop until we have all positive exponents. So notice this property now looks like property 2, or this problem now looks property 2. We have a negative exponent. It can be flipped to the denominator to become positive. So b to the positive 8th. And because we didn't have anything that stayed in the numerator, we would need to put a 1 in our numerator. So that is one way you can work it to get in simplest forms. Let's see if we can find another way to get to that same answer. So start with our problem, b to the 11th over b to the 3rd, all of that raised to the negative 1 power. Let's start with that negative 1 on the outside. So that property says if we've got a negative exponent on the outside, we can flip our fraction. It makes that numerator become positive. So b to the 3rd, b to the 11th, all of that raised to the positive 1 power. A positive 1 exponent really is not necessary to write, so really this is just b to the 3rd over b to the 11th. So that property says we can subtract 3 take away 11 is negative 8. And because we have a negative exponent, it is going to get moved to the denominator as a positive. So notice it is the same solution, or the same simplified answer, and almost the same amount of steps.